Hey everyone, welcome back to Python 101. And today we're on week 13, part 2. So, yay! Oops, wrong one. Okay, so first we're going to talk about the debugger. So you've probably used a variety of print statements to try to find errors in your code. A better way of doing this is by using Python's built-in debugger module, PDB. The PDB module implements an interactive debugging environment for Python programs. It also features to let you pause your program, look at the values of variables, and watch program execution step by step so you can understand what your problem actually does and find bugs in the logic. This is a bit difficult to show since it requires creating an error on purpose, but hopefully this simple illustration illustrates the power of PDB module. All right, so before I continue on let me open the Jupyter notebook first. Hold on. Where is it? Oh, there it is. So here I am. So before I do that, I just need to say that I cut my finger. Yay! And it's like 3 millimeters deep, so it doesn't matter. Anyway. Okay, so we're gonna create a new Python file. We're gonna name it week 13 part 2. All right, so here we will create an error on purpose, trying to add a list to an integer, which if you remember, you can't do that. Okay, so let me just get the keyboard over here. So we're gonna create list 1, 2, 3. Here y equals 2 and z equals 4. Sure, why not? And then here we're gonna do result equals y plus z. Now we're gonna print result. Oh, I can't type with my cut finger. All right, so gonna do that. So now we're gonna do another result. Another result will be result 2 equals y plus x. And if you remember, you're not allowed to do that unless you're in another language. And I don't know. Pretty sure other languages are weird, but like, okay. And now we're gonna print result 2. So here it's gonna give us an error. It's gonna give us 6, and then it's gonna give us an error. So, looks like we get an error. Let's implement a set trace using the PDB module. This will let us pause at the point where it's wrong. So here we're gonna import PDB. That's PDB. All right, now here we're gonna set a tracer. Ouch, okay. Oh, okay, so let's make it more space. All right, so we're gonna PDB dot set trace. We run that. Great, now we can see checks, and here we can see that. So now we get this, and so now we can use Q to, oops. So here it's gonna tell us what we did wrong. So this is the only code. This I didn't write, and So here we go. It tells us what we did wrong, and then here we quit. Okay, so okay. So now we're going to talk about another thing. We're going to talk about time it. So sometimes it's important to know how long your code is taking to run, or at least if a particular line of code is slowing down your entire thing. So this module provides a simple way to time small bits of Python code. It has both a command line interface as well as a callable one. It avoids a number of common traps for measuring execution time. So here, what we're going to do is go to the Jupyter Notebook. Get some more space. So what we're going to do is we're going to import timeit. Let's use timeit to time various things. And yeah. So what we're going to do is we're going to time how long it takes various methods to get from 0, 1, 2, 3, 4, count to 100 and have spaces in between. So we're going to do time it, and here we're going to set 2 arguments, and we're going to use .join, so it joins in between numbers. Oops. Okay. And here we're going to do number equals 10,000. So this is how long it takes to do this 10,000 times. So, and this is also a for loop method. So next we're gonna, and you might see that your times are a bit different because your computer isn't perfect either. Ooh, I just got faster. I just got even faster. Oh, yeah, it's slower. Anyway, if your computer is different from mine, it's okay. Mine might be worse, might be better. Anyway, all computers are made different. Okay, so now here we're gonna use list comprehension. And for now, we're gonna use like the same thing, but we're gonna change a bit. The join here, and then here. And you can see that it's faster than the for loop. And if we map it instead, oops. We get a significant change from this to this to this. So now we know that map is the best way. So we're gonna keep that in mind. So now we're gonna use Python's magic function. I don't know how to say that. Percent sign. Percent sign timeit. Is that how you say it? There's no special name? No, okay, so there's no special name. So if Python's magic thing will perform the same lines of code as a certain time loop, it'll give you the fastest time best of 3. So let's repeat all the things we did above, except we're going to use it magic. So this is magic, time it. We're going to dot join. And here we go. There we go. It's going to give us this. So it's going to give us like the statistics, and that's millisecond. That stands for mu. So probably millisecond. Anyway, that stands for mu in Greek. And so we're going to do the same thing. Except here we're going to dot join this. Oops. And we get faster. We use the map one, we get 26. Okay, so great. So now we get the same conclusion. They're all each different, but they're pretty related to that. So apparently magic slows the things down, and so regular time it is better, I guess, for my computer, I guess. So it might be different for yours, but like I said, all computers are unique. If you like this video, go ahead and, well, you can't really subscribe right now, but go subscribe to my YouTube channel. No, I'm serious. Hold on. Just click a new tab, search up youtube.com, and here we are, and just search EHECHOM. So this one, that's me, that's my weird flute thing, and yeah, okay. So yeah, new video every week. Okay. Bye.